Welcome to the second part of our I was about to say tutorial, that's not what I meant. I meant our exam video. Um, in this video we would look at our code, which you see here. We would also look at the code, the shader inside Unity, and see how it works. Is there anything else we're gonna do?
No, yeah, we'll just go through the code and then show you.
Yeah. So, from the beginning, we start by defining where we can find our shader. Then we go into the properties, where we can create shortcut sliders in Unity, and thereby like we give them a name and we define what they are and what kind of color they have to begin with, and then inside Unity we are then allowed to manipulate these colors and sliders and so on, and manipulate the values of the properties. From there we go into the sub shader.
Yeah, we have only one sub shader in this example, since we're not coding for other platforms.
And we also use one pass.
Yeah, we use only one pass because we're only using one light source in our demonstration here. If you want multiple lights in your scene, you typically use more passes.
And the first thing in the pass is the tag, and the tag here tells Unity when to render it in, like when to render this pass inside the Unity lighting pipeline. It uses the forward base, which I believe is that it will be rendered first.
Yeah, it renders.
You looked it up?
Yeah, so it's like it renders ambient light and stuff like that with those things. So if you would have other light sources, like additive light sources, there's other tags for that. We won't go into that here.
So the thing about writing shaders inside Unity is that you actually write it in two different programming languages. First you use the shader lab inside the mono-develop, and then you move into the CG program, which is where you will write your the property, the shader that you're using, and this will actually not be run inside Unity, but rather on the graphics card.
Pass. At least, this just tells it to go to CG programming language.
The first two lines we have in our CG program is our vertex and our fragment, and basically tells Unity which one is our vertex function, which will be the vert, and which one is the fragment function, frac. And in here we define some variables that are then connected to our properties in the top. So you can see that we create the color that can then react with the property outside of the shader, and thereby allow us to interact with it through Unity.
Maybe we take over a bit here.
Sure.
Oh, can't see. Oh well. Alright, so here we have our two structs, which is just common to all the shaders you'll see in we had a little bit of technical problems. We're back. So here, yeah, we have the two structs which are common in all the shaders you write in Unity. The first one is the vertex input struct, which stores the position and the normals of our model in the vertices. And the second one we'll use to pass on to our fragment function. You'll see down here. And this is basically to translate from the vertex input into a way that Unity will know how to place these vertices and pixels in the Unity space, so to speak. And we'll see this in the vertex output function, which you can see right here. It returns the vertex output, and it takes in vertex input. So in the vertex input we have stored, as I said, the position of the normals, and we then inside the vertex output, the vert function, translate and then store some of these into a vertex output called O, which is then going to be returned here in the end. And as you can see here, the normal directions we get by normalizing, which is to set the vector to a magnitude of 1, and then we have some code which we will not go into detail in here, but suffice to say that this translates it into the way that Unity understands. We can see that we use the normal here from our vertex input struct to to figure out where to put this object in the world space, basically. No, sorry, the normals in the world space of Unity. And here we position the vertices inside Unity. In this one right here. And let's see here. Some of the noteworthy stuff is the rear direction. Let me just take this one here. I'm gonna go into that. Or should I do? And here we have our basically our viewer direction, which is based on the camera that we placed inside Unity. And lastly, the light directions, or the light direction is it's translated here, and then we return it in the end, and we use this struct with these 4 values here translated inside this function to determine our fragment function, which we will go into now.
Alright, so the next thing we will go into is the fragment function called fract. It takes the values from the vertex output, and the first we do in the fragment function is to calculate the dot product of the normal direction and the light direction. So in this variable called dot of normal light, we first saturate, which makes it into a value between 0 and 1, and then we take the dot product of normal direction and light direction. And then we have the gradient of the diffuse, where we also have make it into a value between 0 and 1. We then look for the max value, meaning which half the max value is diffuse threshold the higher value, or is the dot product the higher value. And then we take the highest value and minus the diffuse threshold. We then time it by the power of 2 minus diffusion to the power of 10. The specular gradient looks for the gradient of the specular color, and it also makes it into a value between 0 and 1. Finds the max value of shininess and the dot product of reflect and the view direction. And reflect looks at the negative light direction and the normal direction.
And and this finds the reflected vector of the light and compares it to the camera vector, as Casper just said.
And they then subtract shininess from the max value. It then times it by the power of 2 minus specular diffusion to the power of 10, just like we did in the diffuse gradient up here. And this is done simply to make the cutoff line on the shader sharper and more visible and more cartoon-like.
Yeah, we can use it in our properties that we set in the beginning, so we can manipulate it from inside Unity directly.
Exactly.
Which is awesome.
Super awesome.
You want me to say this last part?
Sure, if that's
you
what
can
you
take-
feel like.
You can take it.
You can take it.
You can take it.
Okay, so I will take it. So the next part, like we were talking about, is the lighting from the shield that creates this Toon-like look. And this is where we add up the ambient light, the diffuse light reflection, and the specular light reflection. And this the variable called light final, which contains the ambient light, where we take one and subtract diffuse gradient and then times it with the unlit color. We plus that with our diffuse light reflection, which we then plus with our specular light reflection.
Yes, and then in the end we return this variable plus an alpha value of 1, just because that is what Unity wants, and we do not want any transparency. And this is actually the entire shader. And just to end it off, we have the NCG, meaning we're going out from the CG program, and if our shader fails, it is told to fall back on the specular shader. So let's take a look at this in Unity and see how it looks. Alright, so you can see our character to the left with no outline. And if we want to, we can try to...
You mean to the right?
Oh, sorry, to the right. We can try to mess around with the lighting. We have a directional light out here on the right. And if we move that around, we can see everything works as it should.
And on the left side we have an example of the state of the art. This is Unity's own Toon shader.
So let's try to mess around with the material on our character.
Yep.
See how the different values that we already in works.
Like this. So. And here we have our shader. You can see the shortcut name here and the different properties that we set that we defined and named in the beginning of the program. We can change the colors of this is a lit color and the unlit color, which will be the shade.
Yeah, kind of the parts where the light isn't touching around.
Exactly. And we have the specular color.
And also we can kind of mess around with the smoothness of the translation between the different, like we have basically 3 colors, right? We can play with the transitions. If we go and change the diffusion and then the specular diffusion, let's try to do that. This one here, yeah, there you go. So you can see it becomes more smooth and more Fung-like, more realistic, less cartoony. And we can do the same here with the diffusion between the lit and the unlit color, which is funky. And I guess that's basically almost everything, isn't it? What do we want to just again here in the end? Just a disclaimer: we did use online resources. Once again, Unity Cookie and Unity Wiki was very helpful. Just a disclaimer so we don't get into trouble if you think our code is too similar to some of the lines of code out there on the internet, because we did use some of it for inspiration. Anything else to add?
I think that would be it. We've gone through our code.
Yeah. Alright, thank you.
We have seen our fine shader in work, and we've looked at some state-of-the-art pictures from different games that use Toon shaders. So with this we would like to say thank you for listening, and see you next time. By the way, there's no more parts of this exam video, so you don't have to look for part 3. This was it. Alright, bye.